In a holographic universe, there are no limits to the extent to which we can alter the fabric of reality. In his books Gift of Unknown Things, the biologist Liel Watson describes his encounter with an Indonesian shaman woman who, by performing a ritual dance, was able to make an entire grove of trees instantly vanish into thin air. Watson relates that as he and another astonished onlooker continued to watch the woman, she caused the trees to reappear, then click off again and on again several times in succession. Although current scientific understanding is incapable of explaining such events, experiences like this become more tenable if hard reality is only a holographic projections. Perhaps we agree on what is there and not there because what we call consensus reality is formulated and ratified at the level of the human unconscious, at which all minds are infinitely interconnected. If this is true, it is the most profound implications of the holographic paradigm of all, for it means that experiences such as Watson's are not commonplace only because we have not programmed our mind with the beliefs that would make them so. In a holographic universe, there are no limits to the extent to which we can alter the fabric of reality. What we perceive as reality is only a canvas waiting for us to draw upon it any picture we want. Anything is possible, from bending spoons with the power of the mind to events experienced by Carlos Castaneda during his encounters with Yacu Brujo du John for magic is our birthright, no more or less miraculous than our ability to compute the reality we want when we are in our dreams. Indeed, even our most fundamental notions about reality become suspect, for in a holographic universe, as Pribram has pointed out, even random events would have to be seen as based on holographic principles and therefore determined. Synchronicity principle suddenly makes sense, and everything in reality would have to be seen as a metaphor. Even the most haphazard events would express some underlying symmetry. Whether Bohm and Prebham's holographic paradigm becomes accepted in science or dies an ignoble death remains to be seen, but it is safe to say that it has already had an influence on the thinking of many scientists. And even if it is found that the holographic model does not provide the best explanation of the instantaneous communication that seems to be passing back and forth between the subatomic particles, at the very least, as noted by Basil Healy, a physicist at Birkbeck College in London, aspects finding indicate that we must be prepared to consider radically new views of reality. Information in the holographic universe. Theoretical results about black holes suggest that universe could be a gigantic hologram. An astonishing theory called the holographic principle holds that the universe is like a hologram, just as a trick of light allows a fully three-dimensional image to be recorded on a flat piece of film. Our seemingly three-dimensional universe could be completely equivalent to alternative quantum fields and physical laws painted on a distant, vast surface. The physics of black holes, immensely dense concentration of mass, provide a hint that the principle might be true. Studies of black holes show that although it defines a common sense, the maximum entropy of information content of any region of space is defined not by its volume but by its surface area. Physicists hope that this surprising finding is a clue to the ultimate theory of reality. Ask anybody what the physical world is made of, and you are likely to be told matter and energy. Yet, if we have learned anything from engineering, biology, and physics, information is just as crucial as ingredient. The robot at the automobile factory is supplied with metal and plastic but can make nothing useful without copious instructions telling it which part to weld, to what, and so on. A ribosome in a cell in your body is supplied with amino acid building blocks and is powered by energy released by the conversion of ATP to ADP, but it can be synthesized no protein but it can synthesize no protein without the information brought to it from the DNA in the cell's nucleus. Likewise, a century of development in physics has taught us that information is crucial player in physical system and processes. Indeed, a current trend initiated by John A. Wheeler of Princeton University is to regard the physical world made of information with energy and matter as incidental. This viewpoint invites a new look at venerable questions. The information storage capacity of devices such as hard disk drives has been increasingly by leaps and bounds. When will such progress halt? What is the ultimate information capacity of a device that weighs, say, less than a gram or can fit inside a cubic centimeter, roughly the size of a computer chip? How much information does it take to describe a whole universe? Could that description fit into a computer's memory? The mysterious properties of black holes. Physicist has deducted absolute limits on how much information a region of space or a quantity of matter and energy can hold. Related results suggest that our universe, which we perceive to have three spatial dimensions, might instead be written on a two-dimensional surface like a hologram. Our everyday perception of the world as a three-dimensional would then be either a profound illusion or merely one of two